We're going to continue topic 2.5 and 2.6, and we're still working on example 4. We're going to finish it up this time. So I'm going to rearrange the algebra first. So I'm going to say that this is the same as saying f of x equals 1 over x times x to the, and I'm going to convert this into fractional exponents, 5 halves power, because again, there's a 2 out there in that root. When I'm multiplying, I know I need to add the exponents. So we get, that's 2 halves, so because I need something with a common denominator, so it's x to the 7 halves power. Now I'm going to take this and bring it upstairs by making the exponent negative, so x to the negative 7 halves power. So I have done no calculus so far, just algebra. Now we're finally ready to do the calculus and take a derivative. I'm going to bring my exponent in front, so negative 7 halves x. I'm going to subtract my new exponent, which is negative 9 halves. So subtract 1 from my exponent. It could be left like that. You might also see that they take the variable and put it back in the denominator because the exponent's negative. So it could be negative 7 over 2x to the 9 halves power. All right, on I, I'm going to convert to fractional exponents first. So f of x equals x to the 4/5 minus x to the 1/2 plus x. And then I'm going to put them all, I'm going to split up the fraction and put them all over the same common denominator. I know that when I'm dividing, I can subtract my exponents, but I need to make my exponents have common denominators. So in this case, it would be 5 halves. In this case, it would be 2 halves. In this case, they just cancel and I get plus 1 at the end. So we have that f of x equals 4/5 minus 1/5 would be x to the negative 1/5. 1/2 minus 2 halves would be x to the negative 1/2. Now we are ready to take our derivative. So I use my derivative notation and take the exponent and move it in front. So negative 1/5 x. I'm going to subtract 1, which would be subtracting 5 over 5 in this case. So negative 1/5 minus 5/5 is negative 6/5. Minus x, we're going to subtract 1, which is negative 2 halves. So negative 3 halves. And then this one here is derivative of a constant, would just be 0. The only thing we could do to make this clean it up at all would be to move our variables back downstairs because of the negative exponent. So it might be 1 over 5x to the 6/5 power minus 1 over x to the 3 halves power, and then plus 0 I could just drop. So J is something they will sometimes do to us is they will make a variable look a variable like a constant. Typically, they will use K or C to represent a constant of some kind. So we're just going to pretend like this and this is a number. Okay, so I'm going to rewrite before I take the derivative because I see I have a radical there that I can turn into a fractional exponent. So I have 3x to the 4th minus kx squared minus kx to the 1/2 plus 4. I'm going to go ahead and take that derivative. So I move my exponent in front. I get 3 times 4, which is 12. X to the, I'm subtracting 1/3. 2 times k, which would be negative 2k. I'm going to subtract 1 off the exponent, and I get x to the 1st. I'm going to bring the 1/2 in front. So 1/2 times negative k would be negative 1/2 k. X, I'm subtracting 1, which is going to look like 2 over 2 to the negative 1/2. And then the derivative of a constant is 0. I'm going to go ahead and clean it up one line. So minus 2kx minus, and this would keep a k on the top and bring this downstairs. So it'd be 2x to the 1/2 and then plus 0. And I could, if that wasn't my answer, so as in I'm doing multiple choice, it wasn't my answer choice, I could reconvert this into a radical of square root of x.